So we have the quadratic equation y equal to x squared plus 6x plus 7, and we're going to be going over how to convert it from standard to vertex form. So I'm going to be showing you two ways to do this, so let's jump to the first way. So right now this quadratic equation is in standard form, and any quadratic equation in standard form is in the form of y equal to ax squared plus bx plus c. Now we want to get it to vertex form, and vertex form is basically any quadratic equation that's in the form of y equal to a times x minus h squared plus k. So for the vertex form equation, we need the following, which is a, h, and k. Now the a in the standard form and vertex form are actually the same values, so we already have our a provided in this equation. Now the a is basically the coefficient in front of the x squared. Technically there is nothing in front of our x squared for this equation, but when there's nothing, it just means that the coefficient is 1. We just don't write it. So a in this case is 1, so we just need to find our h and our k. Now to find our h and our k, we are going to be utilizing the vertex formula. Now the vertex formula is basically negative b all over 2 times a, and this provides us our h, which is the x coordinate of our vertex. So we're going to plug in the b in our a. So the b in this case is 6, and then our a is 1. So when we plug those in, that'll give us negative 6 all over 2 times 1, which will give us negative 6 divided by 2, and negative 6 divided by 2 is negative 3. So we get our h being negative 3, so the last thing we need to do is we need to find our k. Now to find our k, what we're going to do is take our h and plug it into our equation. And when we do that, that'll give us negative 3 squared plus 6 times negative 3 plus 7. And negative 3 squared is 9, and then 6 times negative 3 is negative 18. That'll leave us with 9 minus 18 plus 7. 9 minus 18 is negative 9, and then negative 9 plus 7 is negative 2. And we get our k being negative 2. And basically our k is just the y coordinate of our vertex. But now we have our a, h, and our k, so what we're going to do is plug it into our equation. So that'll leave us with 1 times x minus negative 3 squared plus negative 2. And we're going to clean it up. And when we clean it up, we'll get y equal to x plus 3 squared minus 2. And that is our vertex form of this equation. So that is the first way, but now let's jump to the second way. So the second way that we are going to convert this is utilizing the complete the square method. Now this may ring a bell because typically we use the complete the square method to solve and find the solutions to our quadratic equation, but we can also use it to convert our quadratic from standard to vertex form. So starting fresh, we have y equal to x squared plus 6x plus 7. So when it comes to completing the square, we always want to isolate our terms with x's on one side and then move all the numbers to another side. So in this case, we have this plus 7 here, so we are going to move that to the left side for now by subtracting 7 on both sides. And when we do that, it'll leave us with y minus 7 equal to x squared plus 6x. Now the next thing that we're going to do is we're going to add spaces to both sides. Now, why are we doing this? The reason being so is because we want to create what we call a perfect square trinomial on our right side, because when we do this, it'll allow us to factor our left side to get it in the form of x minus h squared, which is what we want because that will help us get to our vertex form. So in this space, we're going to take the coefficient in front of our x, which is 6, and we're going to divide it by 2, and we're going to square it. And you're probably wondering, okay, why are we adding it to the left side as well? And that is because, remember, what you do to one side, you do to the other to keep the equation balanced, okay? So when we clean up our space, 6 divided by 2 is 3, and 3 squared is 9, and that'll leave us with y minus 7 plus 9 equal to x squared plus 6x plus 9. So now on our right side, we have our perfect square trinomial, which means we can now factor it. So to factor our perfect square trinomial, a little trick that you can do is you want to take the first term, which in this case is x squared, and take the square root of that, and the square root of x squared is x. And then you want to take your last term, which in this case is 9, and take the square root of that, and the square root of 9 is 3. And then you want to take the sign in front of your middle term, which in this case is 6x, and the sign in front of that is a plus sign. And then you want to factor it as follows, where it'll become x plus 3 squared. Okay, so we're left with y minus 7 plus 9 equal to x plus 3 squared. We can clean up our left side because negative 7 plus 9 will give us positive 2, and that'll leave us with y plus 2 equal to x plus 3 squared. And the last thing that we need to do is just solve for y again because we want to get in terms of y. So we're going to move that positive 2 back to the right side by subtracting 2 on both sides. And when we do that, that'll leave us with y equal to x plus 3 squared minus 2. And that is how you would convert this quadratic that's in standard to vertex form using the complete the square method. But that is essentially 2 ways that you can go from standard to vertex form. And that pretty much wraps up this video. But I'm curious to find out which way do you prefer. Let me know in the comments. But that wraps up this video, guys, and take care.